Okay, this is week 2, Web233, JavaScript. No class this week for Martin Luther King holiday. Do want to start though with going over what to do this week. Week 2 discussion and exercise we'll do in just a moment. We'll go over some notes, examples, and an in-class lab. If you've not yet signed up, I did send you a link from repl.it as an invite. You'll need to log in or create an account through that site. Log in to access the lab. We'll be using that for the in-class labs each week. Week 2 reading, this is actually for next week. We do the reading each week for the next week, so you'll be ready. It's chapter 3 over functions. Week 2 assignment. We'll go over that. As always, submitted and through Plunk. In each assignment, there will be a setup and submit Plunk link to show you how to do it. And we'll go over that at the end here. Week 2 discussion, discussing some content about this week's content, your thoughts. And then week 2 podcast is basically what you're listening at right now. So week 2 discussion and exercise is 2 readings, online reading or text, values, type, and operators, and program structures. I'm going to click on this one here first, Web 233.2, and then we'll do Web 233.2.1. Okay, expand this window a little bit here. So we're going to look at data storage and look at first about a song. You are sad, the night said in an anxious tone, let me sing you a song to comfort you. The name of the song is called Haddock's Eyes. Oh, that's the name of the song, is it? Alice felt interested. No, you don't understand, the night said, and looked vexed. That's what the name is called. The name is really Aged Man. Then I thought, then I ought to have said, then what's it called? Alice corrected herself. No, you oughtn't. That's quite another thing. The song is called Ways and Means. But that's only what it's called, you know. Well, then what is a song? Said Alice. By this time, was completely bewildered. So what's in a name? You've got a white knight given a confusing pile of nomenclatures for a song. The song is sitting on the gate. The song is called Ways and Means. The song's name is Aged Man, and the song's name is called Haddock's Eyes. The complicated terminology between this song basically is what etymologists and linguists call use, mention, distinction. In programming, we see this a lot where there's symbolic names for data values, memory locations like values, variables, references, buildings, and scope, all of them meaning certain things within the programming language. So data storage, you got basically your variables and assignments. Data values must be stored in your computer memory. Data storage is done by the assignment statement. That's the equal sign to the right of the variable name. An assignment is putting a data value into the storage location in memory. It could be string, could be an integer, could be a number, a double, float, decimal. Such storage location used by your program is called variable. And again, some of this is recapping from first week here. Variable means the stored value can vary, and a variable does have a text name, and you need to make sure that it's a valid name and that it means something within your code. Making variables like a container or a box, age 47, speed negative 5.312, title the island of Dr. Murray, assignment operator in between the variable name and the value. So in this way, the variable age reads and gets the value 47. Here's an example assignment statement in JavaScript. Age equals 47, semicolon, speed equals negative 5.1312, semicolon, title equals, in quotes, the island of Dr. Moreau, semicolon, gear ratio underscore 3 equals 0.27, semicolon, and done equals false, semicolon. I know we went over this last week, but again, reiterating, semicolon is at the end of almost every JavaScript statement. A statement would be the syntax from which programs are complied or composed, and compiled as well. So a program executes by going from one statement to the other, top to bottom, and what's called statement calls. So far, we've looked at assignment statements. We've used an alert statement to call a certain function or a string. So detail, we're looking at a lot of detail here, basically, and looking at principles. And an assignment, or the assignment operator, we have all glommed up into data storage, data retrieval. So data retrieval, and in data retrieval, you have expressions and evaluation. Once data values are stored in memory, we need a way to get them back. Data retrieval is done using expressions and evaluations. Expressions are formula built from variables, values, operations, and expressions. And here's some examples. Evaluating expressions. When you're evaluating an expression, you mean the formula, turn the formula into data value. Rules define how this is systematically done. And a constant evaluates to itself. So 5 stands for the integer 5. A variable evaluates the data value stored in its memory location. So for right now, x is 17.3, but it could change because it's a variable. A complex expression, when you're evaluating expressions, is evaluated by the first, evaluating the simple parts, then combining those into operations. So if you have dx equals 17.3, dy equals 20.5.4, dx plus dy evaluates the 17.3 plus 20.514 to give you the sum of 37.814. You could also write it as total equals dx plus dy causes the variable total to become 37.814. So operator order matters, again, rehashing from last week. What is 48 divided by 2, 9 plus 3, question mark? Well, the answer depends on the order of evaluation. It also depends on how we handle the implied multiplication. Is it 48 divided by, and then in parentheses, 2 times 9 plus 3 in parentheses, or 48 divided by 24? Or maybe, is it 48 divided by 2 with parentheses 9 plus 3, and we use what's called PEMD as? Or the last one. So depending upon the order of the evaluation depends upon the order of precedence, and where you have your parentheses, where you don't have your parentheses, depends upon the order of your math. As you see in these examples here, outcome of this will always be 288, 48 divided by 2, and 9 plus 3 in parentheses. So JavaScript has no implied multiplication, so you need to be explicit. No implied anything in expressions, must be in all operators. Put parentheses in liberally. just to be sure you get the program to do what you want. So lots of parentheses don't cause extra work, but they do cause extra clarity. So it sometimes takes some thought when you're doing mathematical equations in JavaScript, but just like in any language, it's well worth the time and energy to put that thought in. So now we go back to the first program that we looked at and some changes. So var years, variable declaration, var months, another variable declaration. Years equals 42, semicolon. This is the assignment. 42 is the value now of years. Next, months equals years times 12 is the expression evaluation, which will be years times 12. And the assignment of years times 12 into months. So if a person's age is 42, which is years, in months this is 42 times 12. Take it back. Yeah, 42 times 12. Alert years, which would be 42 times 12 years is, or 42 years, which is 42, years is however many months years times 12 is. So rules, your author limits, all the prior programming instructors who've insisted lots of rules, limit the natural awe and wonder of students who have their captive minds freed from programming. While I am overall sympathetic to the point, we have some rules to go by, and they're just for your own comfort and safety, like keeping your hands and feet inside the vehicle. So declare your variables is the first one. Make sure when you declare your variables that you also can pop up using Chrome. It says Firefox in here, but I recommend Chrome as we did last week. Firefox used to have a much better web developer platform, but now Chrome has surpassed it. And when it says use strict, basically that put this in the first line of your program, exactly quotes and all. Will give you error messages, variables are ever undeclared within your code. So expressions like functions on native type, some operations convert values of type into value of a different type. So alert message in quotes will give a pop-up box. Number 25.4 is going to give you 25.4. Negative minus 73 is going to say true. So some operations convert values of one type into different values of another type. Like for instance, the floor. Floor 5.2 is going to give 5. So functions is what we're going to be talking a little bit about as far as the next few slides here. So you have a name for the function and some arguments in the parentheses. So a function name can be number, and you're sending to that function an argument 25.4. A function name can be length, and you're sending to that argument function ABC. It could be negative 73, myfunc, negative 12, no, and 3.1159. So when you see a function name and an argument, you can expect it to run and produce a result value. Sometimes we see a function invoke what's called a dot notation. So if we have a variable called line and it's 12.75, the length of that line here would be 5 because of the dot operator. Line.parseInt, we can integer that and would give us a 12.75, a number, not a string. We'll look more at that later. So function calls are expressions. A function name with the argument is referred to as a function call. A function call by itself produces a value, so it's an expression. So a function call can appear as part of an expression like 12 times number, 47 in quotes, semicolon, miles equals math.floor. And math.floor is a mathematical method built into JavaScript. Time speed plus init. semicolon. So in this example here, number is a function, and then math times math plus or dot floor is a built-in function. Number 47 is also a built-in function. You're converting 47 to the actual numeric value of 47. So these are both built-in functions in JavaScript. So you began by looking at the big six concepts. We'll look at data, numbers, booleans, strings, operators. Saw data storage, variables and assignments, data retrieval, expressions, evaluations, functions and expressions. We looked at a program and wrote a program on declaring variables. You've already read chapter 1, hopefully, and ready for chapter 2 as well. And I do recommend, as it says in the last bullet, spicing up your practice programs. You can add more to it. You can play around with it, and even the online text that we use allows you to do the built-in compiling within the text using the Control-Enter key. So that's the first presentation. The second one we're going to look at is repetition and repetition loops. So increment, decrement, and shortcuts. Often we need what's called a bump up in a variable value to add a little to what's stored there. An example would be if you're creating a variable type, you want to increment it in a loop by 1 each time. That's an example. Or you wanted to decrement it by 1. So the pattern is that the same variable name on both the LHS and the high or the RHS of an assignment. So here the variable is incremented by 1. All forms means the same things. So x equals x plus 1 or x plus equals 1. X plus plus. And you'll see that one used a lot. So we can increment more than 1 by just changing the increment. So x equals x plus 2, x plus equals 2, h equals h plus 9, h plus equals 9. We can also increment some variable amounts. It doesn't have to be just constraints. And so we can actually have a variable name as an increment. So in this case, it could be distance equals distance plus current miles, speed equals speed plus time times Excel, speed plus equals time times Excel. And so in these 3 examples here, you could have miles, time times Excel as your increment. We can use more than just a plus symbol also. Although the word increment usually is bumped up for an addition, you can do speed equals speed times 2, speed times equals 2, factorial equals factorial times num, factorial times equals num. You can bump down a variable also called decrement. So max equals max negative 1, max negative equals 1, and max negative negative. High end equals 10, high end negative equals 10. Upper equals upper negative 1 or negative num, upper negative equals num, upper equals upper divided by 2. And where it says on this slide here 10, that would be a constant. Variable on the bottom example for upper would be an example of num would be a variable, and even upper would be a variable. So repetition, oftentimes we need a set of operations to repeat things over and over again instead of having multiple if statements. So it's called in programming, lather, rinse, and repeat. So it's iterations of code over and over again until something breaks it, whether the user says yes or no, they don't want to continue, or a value matches that iteration and breaks out of the loop. So an example is some calculations here first. We declare 3 variables, first num, second num, total. First num gets an input from the user for first number, converts it to a number, puts it in the variable first num. Second num, same thing for second number, puts it in the variable for second num. And then finally, the total equals first num plus second num. And the alert is their sum is total. But what if we want to keep repeating this multiple times? Perhaps the user might have more than one number that they want to add. So here's an example. We could do multiple instances of that, we just did, by duplicating it 2 more times. Is it right to do it that way, or is it good to do it that way? Here's another one, repeating it 10 times. What about 100 times? What about 500,000 times? What if we want to repeat until the user's tired of it or out of data? How many times would that be? Again, we could copy and paste to infinity, but is that really scalable? So a better way to be loop it and looping the syntax. And so using the loop syntax specifies 2 important components: the collection of a program that we want to repeat, the loop body, and how many times we want to repeat that collection, the number of iterations. So an example for pseudocode on this would be how to create a 20 tulip bouquet. So you repeat 20 times all these steps: cut a tulip, trim it to a proper length, put it in a vase, and arrange it to a pleasing look. And keep doing that 20 times. Another one. 4, define a condition like 11 times, 1 per car. Repeat, wash each car's windows, grease the wheel axles, and touch up the car paint. Another one, sprucing the train. Start with car 1, stop after car 11. Repeat, wash car windows, grease wheel axles, touch up car paint. Next, move to the next car. The 4 loops are a lot like this, and they work in a sequence. So definite loop is a specific number of times, like counting the items and collections, for n times do all these statements. Where n is would be a specific number. And this isn't JavaScript syntax, but you can get the gist of the concept of it. So for a loop example in JavaScript, using the example a few slides back, first num, second num, total, all is variable declarations. For var equals 1, semicolon, while 1 is less than or equal to 3, semicolon, it's going to increment each time to the next. So it's going to do it basically 3 times. It starts with 1, then 2, then 3. It's going to stop at 3 because it's less than or equal, it's going to equal to 3. Loop the body with what you want. In this case, the numbers, first, second, and the alert. If you wanted to do this 500,000 times, you would just change the seed value to the right of the equal sign. User get a cup of coffee and many hours later, finish the loop. Indefinite loop. This would be while a hot iron bar, how many hits an anvil or hits some type of metal. Repeat. Heat bar, red hot, raise a hammer, smack the chisel. Just a continual infinite loop. Indefinite loop, repeat the loop until an unpredictable number of times. So you have while, some condition holds, and then do all of the statements. So an example for a while loop, while, let's look at the variables first. First num, second num, total, we added a new one, more input equals yes. While more input is equal to yes, and it's important on the equal sign to put 2 of them. If you put 1 there to the right of the assignment operator, it would just mean more input equals yes. You're testing here to see if more input is equal to yes, so it's equal to yes, with 2 equal signs. Loop the body with the 2 number prompts, the total, alert, and then finally, lastly, plugging in the more input variable. Do they want to do it again? Yes or no? And probably a good idea to the right of the do again, yes, comma, no. And it's going to keep looping, next, 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 until the user puts anything but yes in the prompt here for the more input. Another example here. User says, I'm done. Let's stop looping. So let's say they do enter, 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 enter. Each time is equal to yes. it's going to loop again. If the user says, I'm done, let's stop looping, it's going to stop the loop. Another, var target, var counter equals 2, var fact equals 1. Target equals number prompt from the user, what number to start with, while counter, which is 2, is less than or equal to target, whatever the number they entered in. You're going to take fact, which is 1, times counter, which is 2. And so the first iteration of this is going to be 1 times 2 is going to be 3. And then the counter is going to increment. The first counter here is going to be 2 plus 1, which is 3. So it says alert target, which the first iteration on this one is going to be whatever they entered in. We'll say they entered in 10. Plus factorial is fact. So this one here, data says it's done, stop the loop, not a user input, an internal variable change is going to happen. So it's going to happen within here that eventually a counter is going to become less or equal to target. When it does, it's going to stop the while loop. And then you'll get the factorial, whatever the factorial fact is. So if we use a variable of 10 as the target, counters 2 be 2 well, counter 2 is less than or equal to 10. The first time it goes around, a counter would become 3. So second time around, we're okay. We're at 3. 3 less than or equal to 10. Yep. Go again. Now counter becomes is 3 now. Plus 1 is going to be 4. Keep going. 5, 6, 7, 8, 9. And when it gets to 9, it's going to come back up here to 10. And it says here, counter less than or equal to target. It's going to stop on that loop. So in general, a loop is definite, specific number of iterations. A while loop is an indefinite, known as unknown number of iterations. Loop until a user says I'm done, or loop until data says it's done. Counters and accumulators. Counters and accumulators are common in patterns for variable use. Remember the increment concept or decrement. A counter is an increment inside a loop, and it's usually incremented by 1, but not always, but usually it is. So here we have an example of a for loop counter, var max, and then var count equals 0. The variable declaration, initialization. Max right now is nothing, no value, but count does, which is 0. Prompt the user for an upper limit for var 1 equals I equals 1, while I is less than or equal to max. It's going to increment. So when it gets here, we'll pretend here that it 5, max is 5, is what we entered in. So first loop, I is 1, max is 5. So here we have count equals count plus 1. Count is 0, so count's going to be 1, 2, 3, 4, 5. So then it's going to stop here, and we counted here. We counted however many, which in this case is going to be 5. Counter must be initialized outside the scope or the loop before the loop is executed. Accumulator is a generalized counter. A counter in a loop is incremented by a variable amount. Accumulator is used to build a result incrementally, one piece at a time. So we grow the result every time we execute a body. So result equals result plus I dot offset. Factorial equals factorial plus num. Factorial times equals num would also be a counter.
Are you just watching everything, buddy? Yeah. Gotta move so Mimi can get in here and get some. Stuff done. Have me a meatloaf cooked here. Let's see. Oh, am I going to be quiet?
So a for loop accumulator, we have var max, var fact equals 1, being your declaration initialized combined, max number, whatever, max variable, whatever the user enters in, prompt, whatever factorial of what. So for var equals 1, for I equals 1, while I is less than or equal to max, it's going to increment. And once it's done, it's going to pop out an alert, max factorial is fact, whatever the count is. So multiplying accumulator is initialized by 1. And one of the reasons why you want it to be initialized by 1, again, is for the count to be correct. The accumulator example, here we have a var n, var total equals 0, var I equals 1, while I is less than or equal to 5, it's going to increment. Ask the user to enter a number, give a number. Then total equals total plus num. It's going to keep looping until I is less than or equal to 5. And so it's going to loop 5 times. Alert is going to be 5 user inputs, sum to whatever the total might be. It says here an add accumulator is initialized to 0. Why? Again, to help with the 0 array. In this case, 0 array on for loops always start with 0. Even though we're initializing it to 1, it always starts with 0. Okay, so if we started with 1, it would be 2 on the first loop instead of 1. All right. So let's look at the in-class lab. So REPL.it is what we're using. And all you're going to do here basically is declare a variable for an ID, assign your student ID to it, leave the S out, declare a variable for, declare a name and a variable name for ID and assign a value for it, for your student ID. Then display that variable here, and we're going to use a console.log is fine. Declare variable for year of birth and add 10 years. Display that variable for year of birth. Display alert telling everyone good evening, RBC. And then ask user how old they are, and store it in variable. It should be they instead of the. And then finally display variable with an alert. Now I'll do the first one here just to show you. I'll do like var, I'll do ID equals, I'm gonna leave out the O, semicolon. And then here I'm gonna put in the console.log, and then parentheses, I'm gonna do ID. And do a command enter on my Mac, and then be a control enter on your PC, or you can just hit run. And you'll notice down here is where it pops out. 0 is not going to show up because it's going to drop that because it's a variable. All right. If I put something else besides a 0 in there, we'll say we'll put in there a 2 just to show you. I'll go ahead and do a command enter. There you go. It shows up. So if beginning 0, it's going to drop that. All right. So continue that. Once you're done, you'll need to be logged in. Once you're done, you'll hit submit, and then it's going to be complete. And what I'll do is grade it. And going on, reading for next week, chapter 3 on functions. And as always, make sure in your reading to take advantage of the compiler in text where you can see the output. And by the way, one of the reasons I use the REP, the replet is how I pronounce it, is because it's on my end, I can put notes in here, and then I'm going to use this. I think I give you 20 points for your in-class lab to do that. And so, again, just to benefit you and to make it a little easier, it's you're not having to copy and paste the URL like you're having to do for your assignment. It's just something easier to use, hopefully. And again, once you create your own replet, you can do your own for playing around. And just an FYI, this replet does support other languages as well. So, C#, Java, JavaScript, Python, Ruby. And so a lot of different languages, C++, Swift, which is for iOS, which I teach as well. And so a lot of cool languages that it has supported for you. So I think you'll like it. All right. So that's on the assignment. Again, this link here, I'll go and click on to show you. It just goes through on how to set up Plunk and how to submit Plunk. If you click on this one, it's going to launch a YouTube video on how to set it up. This is going to be how to submit a Plunk once you've completed it. So watch both of those if you haven't already, which most of you have since you submitted yours for week 1 already. So let's look at the assignment. This is actually from the text, this assignment is. And as always, I do have the source, which I'll talk about in a second, but I'd like you to try to figure it out without looking at the source first. So you're going to create a new Plunk for week 2, update the index.html to week 2 Web233 assignment, update the script.js with your normal comments, and you're going to create a looping a triangle. So we're going to be using loops in a console.log to output the following triangle. And so in order to do that, you'll notice we've got 1, 2, 3, 4, 5, 6, 7 rows, okay? It might be useful to know that you can find the length of a string by writing what's called a dot length after it. So an example in this here, var abc equals abc, console.log abc.length would be 3. So you can start your program by with a program that simply prints out the numbers 1 to 7. Once you get that to work, then you can figure out the loop to put in however many hash symbols you need to put in, hashtags you need to put in there. So you can go from 1 hashtag to 2 hashtags by adding, remember, the plus equals hashtag that we looked at earlier tonight. And then also the solution is for us as well to look at. And so again, if you can get 1 to 7 to show up properly in a loop, then it's just a matter of using some logic to figure out, okay, how do I get in the first iteration 1, then 2, then 3, 4, 5, 6, 7. And a little tip and trick is using a counter to help you with that. Using a counter to determine how many hashtags to use, okay? Once you're finished, submit your Plunk as always by viewing my Plunks, clicking on the exclamation point and the URL. And let me go ahead and show you here where you can find, if need be, the solutions as always. If I go down to the bottom here, assignment examples. And here is the Plunk for week 2. And if you click on that, it'll show you the source for week 2's assignment that you need. But again, I would say try it on your own, see how well you do. If you get stuck, you can definitely look at the source until it's 4. Then the week 2 discussion is over what benefit does loops serve in programming. And then here's where the link will be for the podcast that you're watching. So again, between now and next Monday, make sure you have done the reading for week 2, which is going to be chapter 3 on functions. And I'll open that up real quick and make sure, as always, as you're reading your content, you can click in that content and do a Control-Enter to see the output variable for that. And this one here is getting a square, calling the square function for 12 and returning it. Console log square, var square equals func x, return x times x. So it's 12 times 12. It's going to return every time this square is called. Here's one for making noise. And I'll end on this one. The variable function, a variable function called make noise equals function, console.log pling. They call that, pling is going to be shown. Down here, another one called power. It's also a function, and it takes 2 arguments, base and exponent. And I'll go ahead and put that one in there. And it's going to take 2 for the base, 10 for the exponent. Keep looping until it finally returns the result of the base, which is 1024. So avail yourself to that. If you have any questions, as always, you can email me. Let's have a great week.